Hey everyone, now in this video we are just going to analyze three of the cases, right? The first case should be like that. Oh, the eraser is on. Now in this case there is an object which is having a mass of m and you are applying some forces. You are applying some forces over here, and this is the first case. In this case, we'll analyze that you have applied lots of forces to move that object with respect to the surface, but your applied force is not sufficient to move it, right? That means the applied force is less than of that friction force, right? That means I can say like that also, that the applied force is less than of mu mg. So in this condition, you will see that the object will not move and the object will be fixed at this position. Now, what is about the second case? In that second case, we'll understand that the object is fixed at this position and you are applying lots of forces. You have tried a lot, and at a particular time, the applied force is able to overcome the friction. That means at an instant, the object is able to overcome the friction. Now, in this case, the maximum value of static friction is known as a limiting friction, right? That means you are trying a lot to move a car, and at a particular time the car moves. That means the maximum value of static friction in this case you have just got, that is known as a limiting friction, right? Now just understand here, in this case we are assuming your applied force is equals to the friction force. That's why the object is able to move from its rest condition. That means I can say that the applied force, that is equals to mu mg. Why every time I'm just writing down mu mg in the place of friction force? Because we know that if the object is having the mass of m, that means it is having a weight of m into g, and the normal reaction force, that is equals to r. The friction force is obviously directly proportional with the normal reaction force, and it is directly proportional with the weight of an object. That means I can represent it as mu mg, where mu is a constant, it is a dimensionless unitless quantity. That's why every time I'm just writing down that one. Now in this case we have just got the value of the force that you will apply, that is equals to the friction force, right? So the expression you have just got, that should be highlighted, because that kind of conditions may be asked in any numerical, and at that time you have to apply that concept. Now what is about the third case? In that third case, that means your applied force is sufficient enough to move that object, right? That means you have applied lot of forces and you are able to overcome the friction in an easy way. That means the object is in acceleration. That means your applied force is very much greater than the friction force. That means the applied force minus of friction force, that is equals to the net force, that means mass into acceleration. Now what I can write from this expression? Let me just scroll down the board. Now in this case what I know, that the friction force, that is equals to mu mg, and in this case m into a will be fixed. Now the value of the force, that is equals to m into mu g plus a. So that kind of expression you will get when you are applying lots of forces and you are able to overcome the friction in an easy way and the object is in acceleration. Now in that case you will get that kind of expressions. Now we have got three expressions. In the first condition, your applied force was not able to overcome the friction. That means the friction force is very much greater than to your applied force. That's why the expression is look like this. In the second case, we have got an expression where the object is able to move when your applied force is just equal to the friction force. That means it's just able to move. That means in that case you will get the value of maximum static friction, that means the limiting friction. So in this case also you have got the value of the applied force. And in the third case, when the object is in acceleration after applying lots of forces and it is able to overcome the friction in an easy way, then you will get that kind of expression, that the applied force minus of that friction force, that is equal to the net force, that includes mass and acceleration. So in this case you will get that kind of expression. That's very much important. So you have to just make it highlighted because questions may come from this concepts as well, right?